So is the promised background for the mixed circuit, and so the task here is to measure. Let me see. I think I'll pause this for a moment. I had to change the tablet settings for my pen here. So there's a variety of quantities here. I total, V total. If you stare at this for a minute, just make sure you understand that the voltmeter, this is the equivalent. It's measuring across the whole circuit, of course, but because the wires are assumed to have zero resistance, it's also measuring across the power supply itself. Okay. And you always take this measurement because for any particular set of things, for measurement theory, because sometimes the circuit, even though this thing, for example, might say 6 volts, you might get 5.5 there. For us, this is not going to happen, but just good measurement science. Okay, so whenever it comes to these circuits, and hopefully this is going to help you for an exam, we have Ohm's law, and you can rearrange it as you needed. But one thing that we always know is true, and you've seen this before in one of the videos, is that I total is always equal to the V total, which is in this case the power supply, and R total is if we add all these up. So at the mixed circuit, it's not as obvious. So you always look for whenever you have a mixed circuit, you look for things that you know how to add together. And so in this case, we notice that R2 and R3 are in parallel. So we know how to add those together. So 1 over R23 equals 1 over R2 plus 1 over R3. So the general least common denominator is just going to be R2 times R3. That's the brute force. And then we know then it becomes R3 plus R2. And remember this, that's what, just to make sure you absolutely understand, this becomes R3, you cross them, over R2, R3, and you see that if the R3s were to cancel out, I'd still get 1 over R2. So then what I do is I take the inverse of both sides, and I get R23 equals R2, R3 over R3 plus R2. Of course, the order doesn't matter. So then we end up with this R1, R2, 3. And then these are two in series, so R1, 2, 3, which of course is our total, equals to R1 plus R2, 3. So right away now, we can find our I total. And that's the V power supply divided by R1 plus R2, 3. So now that's our first one is checked off. Okay, now the V total is known, V power supply. So the way you do these things is that, I'll duplicate this, I think. Now what you do, so the way you do any mixed circuit problem, that's always going to work. I mean, there's ways of finessing it, of course, but you'll always be able to get the right answers if you reduce it down first to a single resistance of R total. So, well, there's Mr. Cursor. So now we have our total, and we have our V power supply, and then the return, just using the shorthand. And now we have I total. Now, if we back up, so now you climb back up. So now we have R1 and R23, and because they're in series, IR1 equals IR23 equals I total. So now we rearrange Ohm's law, and we V equals IR. So V R1, I'll use the nomenclature up top there in the diagram up here, equals I total times R1, and VR23 equals I total times R23. So let's see now. Let's use a different color for this. So we've checked off this one. This one is a given. We gotta measure it though. This one and this one. So all that's left is to figure out the current in the two resistors in parallel. So now we climb back up the ladder. So we have, and we're going to analyze this this circuit fragment. And the circuit fragment is R2 and R3, and the voltage across both of them is VR2, what is it, 23? No, I remember now, VR23. Because they're in parallel, they both have the same voltage across them. So now we use Ohm's law once again. And so I of R2 is V of R23 divided by R2, and I of R3 equals the same VR23 over R2. So you know that, and so the R values you use R values part 1, where we put the 3 different devices under test. And the only reason you wouldn't use them, if remember you have the ohmmeter values. So if somehow you goofed and the R values are really different than the ohmmeter, then use the ohmmeter values to calculate stuff. Okay, now let's move on to the Mercedes symbol. Let me pause this for a minute. Okay, so what you guys are going to do is one by one, you're going to connect the power, with an ammeter, you're going to connect the power supply to each of these resistors, and you're going to measure, you're going to also connect the voltmeter across it. So basically, all V's the same. And so we want to decouple these guys. So let's explore a little bit. I equals V over R. So I AC is going to equal V over RA plus RC. All right, so let's see. We got, suppose what we should do is we should rearrange this so that well, this is one of those ones that I'm gonna just have to let's see, AB, I'm not sure precisely, RA plus RB, and IBC equals V over RB plus RC. And maybe whenever you'd have a certain number of unknowns, you need a matching number of equations. So we have 3 unknowns, so we need 3 equations. And yeah, I think that, let me duplicate this. We want to let's see. I think we should rearrange these. RA plus RC equals to V over IAC, and there is RA plus RB equals to V over IAB. Okay, so you can combine these things. So one thing we can do is we can subtract one from the other. So then the RAs will cancel out. RC minus RB equals V over IAC minus V over IAB. Oh yeah, we're almost home now. So we have, we'll take the last one, RC plus RB equals V over I BC. And so we subtracted those two. Now I'm going to add these two. So the RBs are going to cancel out. And we're going to get 2RC equals V over IAC minus V over IAB plus V over IBC. Okay. So then we can solve for RC. And then you take RC, all right, and so RC equals V over 2 times 1 over IAC plus, minus 1 over IAB plus 1 over IBC. And then you can take that and plug it back into here, if you like. Let me make that an arrow, not a minus sign. And so can't make that any bigger. Okay. So we have RC minus RB, and let's think, that one's long. Let's take an easier one first. RA plus RC equals V over IAC, and then so RA equals V over IAC minus RC. All right, now you got RA, and then we just need RB, right? So then we go back to one of the other original ones, RA plus RB equals V over IAB, and we need RB equals V over IAB minus RA. Done. Okay. So I'll stop this and upload this.